All right, let's start talking about types of mixtures. All right, mixtures and solutions is what we're going to go over in this chapter, mainly solutions, but we're going to start off just going mixtures and solutions. All right, so riddle me this. What is a mixture? What is a solution? Is a mixture a solution? Is a solution a mixture? What's the difference? All right, a mixture is just two or more things mixed together. All right, if they are mixed together homogeneously, we call that a solution. All right, so a solution is a homogeneous mixture of two or more things. All right, what if it's not homogeneous? Then it's heterogeneous. All right, there's different types of heterogeneous mixtures. There are suspensions and there's colloids. So suspension is basically the particles that are dispersed in whatever's dispersing it are big enough for gravity to settle them out. So I always talk about muddy water. So if you imagine getting like a big old cup full of muddy water, it might at first look like chocolate milk, but put it down, leave it on the counter, don't touch it for a couple hours, and all those big dirt particles will settle down to the bottom, and then it'll look like clear water with a bunch of dirt on the bottom. That's a suspension. Now, if the particles are so small that gravity can't even pull them down, we call that a colloid. All right, these particles, they're much bigger than individual atoms or ions or even like little molecules. All right, for like a normal solution, they're big. They're big old giant things, and they can be huge. I guess like protein molecules, but yeah, usually they're things even bigger than that. Just big things, relatively big things that will not be settled out by gravity. So these colloid particles, they're usually anywhere from like 1 nanometer in diameter up to 1,000 nanometers in diameter. Let's click on this. All right, there's lots of different types of colloids. There's gas colloids, there's liquid colloids, there's solid colloids. All right, so a gas dissolved in a solid, an example of that, it's marshmallow. All right, solid foam. We can have a gas dissolved in a liquid. That'd be like whipped cream. A solid dissolved in a gas, or I mean to say dispersed, not dissolved. Solid dispersed in a gas, that'd be smoke. If I have a liquid dispersing gas, that's fog. So if you actually are walking around and it's foggy, sometimes you can actually see the little itty bitty tiny water droplets, but they're so small that they're not falling. All right, they're just kind of levitating there in the air. And a lot of times, these particles are really small, but again, they're bigger than normal like solute particles in a solution. So how can you tell them apart? Like there are plenty of colloids that look to your eye very uniform. It looks like a solution. So how can you tell a colloid from a solution? Well, there's something called the Tyndall Effect. Shine light through it. All right. The colloid particles are actually big enough to scatter light. So if you shine light through a solution, it just goes straight through the solution. But if you're going through a colloid, you're going to clearly see the beam of light. So you see this beam of light coming through. It's kind of like a smoky day there. All right, you can see that. And sometimes like on days, especially when Arizona's on fire, which it's usually on fire. So even if I'm watching this video like 10 years from now, I can always refer to Arizona being on fire because they catch on fire every freaking summer. A lot of times in the afternoon here, when the sun starts going down, you see these cool beams across the sky. It's because there's all sorts of smoke up in the air, and it's causing this Tyndall effect. All right, a couple random things here towards the end. Thixotropic mixtures. It's sort of a liquid, sort of a solid. What the heck is it? All right, like toothpaste is thixotropic. It's kind of a liquid. It's kind of a solid. All right, it's a solid if you're not messing with it. But then when you go to stir it kind of acts like a liquid, or if you squish it, it acts like a liquid. So kind of weird stuff. Random point there. More important, I guess, but also random. Something called Brownian motion. It's the crazy, erratic, jerky motion of colloid particles. If you were to look at a colloid under a microscope, get really up close on it where you can actually see those little colloid particles, you'd see them just bumbling all over the place. Remember the red and blue circles I showed you all crashing into each other when I talked about AMT? They're doing that basically, but what's going on? The reason they're bouncing all over like that is because it's collisions. Well, so whatever the dispersing medium is, that's bonking into it and causing the stuff to move. So you can see it moving because of those wacky collisions. All right, now let's get to the homogeneous mixtures. All right, so a solution is a homogeneous mixture of two or more substances. We can have solid solutions, we can have liquid solutions, we can have gas solutions. Whatever you have the most of is your solvent, and the things in smaller amounts are your solutes. That's all old stuff. All right, here's just a bunch of examples of different solutions, some solid solutions, some liquid solutions, gas solutions, like the air you're breathing is a solution. All right, specifically talking about liquids. All right, liquids that are not soluble in each other are called immiscible. So oil and water are immiscible. All All right, liquids that freely dissolve in one another in any proportion are called miscible. So alcohol, ethyl alcohol, and H2O, they are miscible. They mix in any proportion. All right, and a substance that dissolves in a solvent is said to be soluble in that solvent. Cool. All right, so that's kind of like the nitty gritty. We're going to start talking about concentration in the next lecture. All right, catch you in that one.